start with something basic. हमारे पास है, if you have a calculator, you can open the calculator, and I want to ask question. What is the sine of 30?
Oh, my calculator doesn't go that far.
Calculator में જોયો તમને ખ્યાલ હશે કે क्या આવે છે નથી ખબર હા આમાં સાઇન ની નિશાની હશે આ સાઇન બરાબર અને પછી સાઇન કર્યા પછી 3 0 0.5 right. So one of the calculator is giving 0.5 બરાબર
The 0.5 degrees.
0.5 degree નથી 30 degree છે. Sine means, what is sine? When you have a right angle triangle, this is 30, this is 60 and this is 90, right?
Correct.
So sine, this is A. Sine means opposite divided by hypotenuse. Means this is a 1, this is a 2. Right? So shadow of any object is about half the size. અત્યારે આપણે shadow કીધું, shadow of this object, તો એ actually tangent કહેવાય. But why I'm saying shadow is a sign? Because in space everything is too far. So sun is too far and we get very narrow angle from Earth.
Yeah.
આ અર્થ બનાવીએ આપણે, આ અર્થ બનાવીને આસન બનાવીએ. So this angle is nearly half a degree. Half a degree. Why is half a degree? I'll just explain later on. So small angle doesn't give any difference of this sign.
Yes.
Opposite is this 1 centimeter and this is about 110 centimeter. Right? So it doesn't give a difference whether you take this hypotenuse or take this adjacent. Both are same. So for very such small angle in the space, sine is equal to 10. બરાબર? એટલે not in our in trigonometry but in space for a small measurement, sine becomes equal to 10.
How do you get that number
10 theta.
Tangent.
Tangent.
Okay.
So anybody has got a calculator who gives the wrong answer. Most of the calculator has a wrong program, and if you say what is the sine of 30 degree, it gives 0.98 something answer. Most of the calculators are wrong. Only sophisticated calculators or computer gives the correct answer. We got the answer, so we don't need to remember but where it came from, whether it's true or wrong. Right? Let's see. This circle has a 360 degrees. Yeah?
Yes.
And half circle is 180 degrees.
Yeah.
And we divided it in 3 parts. So each is 60 degrees. Right?
Yes.
So when triangle has all 60 degrees, this is both equal. So this is also equal. So this is also 60 and this is also 60.
Yes.
Yes.
I'm moving in.
Yeah.
Sorry, I'm late.
So,
My son took me to the opera.
so
My son took me to the opera.
oh, I see.
Yeah, he came over from Jersey. So sorry, I'm very late.
So all 3 angles are 60, all three sides are equal, so all are equal to R. This R, this R, this R, this R. And this is also equal to R. R means radius. Right? If we divide this one in two parts, so this will become 30 and this will become 30. Yeah? So naturally, this part also is a half. This half and this half. Yeah? So it means this is half R and this is also half R. So half R divided by R is equal to half. Yeah? So answer is exactly right. So degree 30 sine equal half. This is the proof. Now if we go on dividing this one, every time just say chop, chop, chop. Make a fractions. So 30 degree sine equal 0.5 divided by 6 each. Let's do with the 5s first. Divide by 5s. Yeah? So, yeah, so what we'll get 6 degree equal 0.1. Yeah? So naturally when you do everything on calculator or computer, you will get this answer. 6 degree sine equal 0.1. So you actually don't need to use calculator, don't need to use table, anything, nothing. Don't worry. Just chop it. Again, divide by 12. And here you will get 0.5 degree, which we are looking for. Yeah? Divide by 12. Sorry. 0.8 something, yeah. 87, whatever it is. 0.08, yeah. So actually we don't need to calculate, don't need to rely on anything. Just chop it and you get all the table of sines, all the table of cos, all the table of tangent, everything. You don't need to calculate. Just remember this. Sine is 30. Cut it, cut it, cut it. Right? Okay? That's finished?
Yeah.
Any question?
Not yet.
It's just pro rata and everything done.
Yeah.
Equally. Yeah.
Just do it half, 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 or 110, 110, 110. Go on. Go on dividing. That's the simplest way. Don't need to remember anything. This we are using when we are calculating the sum. Now, anyone has a doubt or any question about this one, because I am not repeating this.
What's the 1 centimetre?
I just take the measurement. If this is 1 centimeter, this is about 110 centimeter. So 1 divided by 110 comes about half a degree, because sine is about this much. So 0.087. This is approximation. We are not calculating exactly according to the calculator. We are trying to just understand how we can do it and how we can approach the answers, especially.
The line. Philosophy of atomic principles.
Yeah.
It's so easy.
Yeah, so easy.
When
Very
you-
simple.
When you do it.
Now I start working on this paper. When you are ready, just tell me.
Let's see.
Have you got my paper?
Did you see the Mars rocket landed on the rocket landed on Mars?
It's crashed, is it?
Yes. It's crashed.
Nothing can land on the Mars. Sorry, not Mars, sorry.
On the
What you are talking about is some...
whatever it is,
Asteroid?
asteroid, yes.
Oh, yeah, asteroid. That's correct, yeah. Okay. Barabar bhai?
Yep.
Okay. Shall we start now? Should I remove all this? Actually, આ બધા છોકરાઓ કોલેજમાં યુનિવર્સિટીમાં ભણતા હોય ફિઝિક્સ અને સ્પેસ અને એસ્ટ્રોનોમી એને આ બધું એટેન્ડ કરીને શીખવું જોઈએ પણ આપણી પાસે ભણવાવાળા કોઈ નથી. હવે first thing is we are just taking the earth rotation speed. Right? Earth rotation is rotation on axis. Okay? So what is earth rotation speed? We have got earth having a perimetry of how much? 40,000 kilometers?
Yes.
We take all in round figure and in approximation, so it will be easier to count for 40,000 kilometers. This one. लिया ना दूसरे. Simple formula what we are using for perimetry is 2 pi r. Right? Our Earth rotates in 24 hours. Right? So 40,000 kilometers are rotated in 24 hours. So 24 hours we multiply by 60 minutes and multiply by 60 seconds. Yeah? So what we will get the answer? See, again it is coming with our old mathematics. How to calculate this? કેમ કરશો? આ 6 છે અને આ 24 છે. What is a middle figure? 30. Yeah? So this is minus 6, this is plus 6. So answer will be 900 minus 36. That will be the answer. Which we haven't done. That is called A plus B, and another bracket is A minus B equal to A square minus B square. So answer will be how much?
864.
64, okay. Is it too much? 24, 36.
30 square is 900.
Yeah.
Yeah, so it's right.
So we haven't got the right answer. That's why I'm worried.
864.
Yeah, that's correct, but we are not getting the right answer for the kilometers. Kilometers per second.
Isn't it then 400 divided by the 864 gives you
Yeah, that's
0.5 kilometers?
If you divide the 4 into 24.
400 divided by 864.
Yeah, but that is correct. Yes, this is good, the right one.
Yes.
So equal 400 divided by 864. It comes about 0.463. 63 kilometers per second. That is how I given the words here. How much it rotates per second.
60 minutes and 60 seconds.
How do you get 30?
Which one?
24 times 36.
Yeah, no. I had taken middle of 36 and 24.
Oh, I see.
When we are calculating two figures, we take the mean of that one, middle one.
Median.
Yeah, so it becomes easy to count.
Yeah.
From 30 times 30 becomes 900. So this is less 6 and this is a plus 6. So we take now 36.
Yeah.
That's it. That's the simplest way of counting, which is in algebra it says A plus B and A minus B equal, when they are multiplied, it becomes a square minus b square. So this is a square and this is minus b square. All done?
So we apply the same full formula, a squared plus minus 2ab.
Yeah, like this one. A plus b multiplied by a minus b. The answer is a square minus b square.
Okay.
But we haven't we have just shown the process, how to do a square and b square. But actually speaking, we don't calculate. We just assume. This is very easy. We assume and take out 36, that's it. So sometimes we say, what is the multiplication of 51 and 49? Yeah? So what is the mean? 50. So we take the 2,500
Yeah.
and take out 1 minus 1. 2499. Yeah? It works that way. So everywhere, wherever there is two different figures, find out the middle one and make a square and take out the difference square. Square of the difference. So
Square of the difference, so 51 minus 49.
yeah, so difference is 1 minus plus 1 and multiply by minus 1. So plus 1 minus 1 is minus 1. Right?
Yeah.
So take out the minus 1. These all are algebraic formulas.
Oh, I wanted that 50.
Yeah, that was good. That was a good example.
I take another one, 52 and 48. So same thing, 2,500 and difference is 2. So 2 times 2 is 4. Taken out 4. So 2496. That's it. જો આપણે આટલા સ્લો જાશું તો આપણું લેક્ચર અડધું થશે એટલે બીજા લેક્ચરમાં આપણે કવર કરવું પડશે ઓકે we just calculated the speed of the earth on its axis on the surface okay so anything traveling more than this speed on the earth
To leave the orbit.
not leave the earth it doesn't stay on the surface. It just tries to fly like an aeroplane. But otherwise what happens? Aeroplane is using the air force in jet air. It's not that speed at the moment. But when it gets this speed, it stays up above. Okay, now let us start to calculate different. Next step. Earth orbital speed around the sun. So should I remove this one? So boleh ni?
Yeah. We need different color pens, then. Make it easier.
Yeah. Same thing. This is the sun, and Earth is going round in elliptical way. So this is the problem of pen. So ultimately, doesn't matter it goes in egg shape, elliptical or circle, ultimately it comes to pi r. That calculation comes in Kepler's law, how much it moves in a particular time.
Yeah.
So we can calculate 2 pi r, but how? Do you know the r? Is 15 times 10 raised to 7 kilometer. Or use, આપણે હનુમાન ચાલીસામાં કહ્યું છે, શું કહ્યું છે? યુગ સહસ્ત્ર યોજન. બરાબર ને? આવે છે? યુગ means 12,000. Sahastra means multiply by 1,000. So it comes about 12 million yojan. Multiply by 8 miles, which is, so it comes
96
about 96 million miles. And multiply by 1.6, it comes about 150 million kilometer.
Where is 8 mile? Is that mentioned in the thing?
That says approximately that
No,
one yojan is about,
Oh,
in
one
distance is about 8 miles.
That's 8 miles and 1 yojan.
Yeah.
Okay.
It doesn't give any Kostak, any tables. It's just assume that that might be the distance. Not in kilometer, not in mile, but it is in the form of yojan.
Okay, and the 1.6?
It's when you convert miles to
kilometers.
Kilometer.
Kilometers.
yeah, that is in our Kostak, yes. So what we are doing here is actually calculating what is 2 pi r. The calculation is given there. Yeah? 2 times 15 into 10 raised to 7, that is that. Yeah? Can you read these small numbers or I have to write it bigger one?
What's the times 1.6 at the end there? On the,
When you convert this one from mile,
yeah,
this is the miles.
and this is kilometers.
Yeah, so when you convert, multiply by 1.6.
Yeah, thank you.
So you got 150
150 million.
million.
Means 15 crore.
Okay.
Yeah?
15 to the power times
Yeah.
10 to the
And
power.
multiply by pi means 3.4. Here we are taking pi because we are trying to understand by our mathematics. Otherwise, none has written pi in Surya Siddhanta or Veda or a Purana. Nothing is there.
So,
But did they understand the concept of pi?
Yes,
They need the number.
yeah, what they are saying, that's where we are trying to do it. What they have said is just do that and compare that and that. That's we are doing. Just comparing. There is no pi at all. Doesn't come at all in the field. We don't write pi. We write the pi only to understand ourselves. That's it.
pi, that's pi r squared, is it, or pi r?
2 pi r.
2 pi r.
2 pi r. Sorry, pi is here, r is here. This is 2. So ultimately, 15 times 6 means 90. It comes about 90 into 10 raised to 7. What is exact figure here? 94.
9424
Yeah.
796.
So I just write 94 and 10 raised to 7, yeah?
Yeah.
And then divided by 365 days, 24 hours, 60 minutes and 60 seconds, and ultimately by division we get only 30 kilometers per second. I'm not going to count everything, this one.
No.
So that gives us 30 kilometers
I thought you
per.
would do it in your head. Did you?
Yep,
I thought you would do it in your head.
Just
Yeah. That's I have given what I have done it. So if you can't do it, then just follow this one. Because if I'm going to do everything, just a demonstration, there is no point.
I just wanted to see you do it in your head.
Right, so anything traveling more than 30 kilometers per second leaves the Earth orbit.
So in other words, when they sort of work out planes, they've got to go faster than that.
Yeah. So first orbit they start at 11 something, leave the Earth, then it goes to first orbit, then another rocket pushes it up in the second orbit, higher orbit, and then the final destination to leave the Earth, they must travel about 30 kilometers per second.
It's come around 17 or 18,000 miles per hour.
About multiply by 3,600 seconds. That will be the speed.
It's quite a lot.
About 100,000.
180, yeah, 180.
That is the speed to travel in the space.
Yes, yeah.
180,000 kilometers
Yeah.
per hour.
That's the sun in the middle, in your diagram.
Yeah, something in it.
And then we worked out the
Work
sun.
out the periphery or circumference is the path of the earth and divide by 365 days.
So we know the earth going on the, we know
Yeah.
the earth going on the sun, yeah?
Yeah,
Okay.
around the sun.
400 miles. per
So
second.
how much it travels the distance and in what time? So it gives about 30 kilometers per second.
It's 400 miles.
Where is 400?
4 miles a second. Divided by
No.
8. Divided by 8.
30 kilometers per
30 kilometer means,
Is divided by
20,
8. It's
20
4.
miles.
yeah, if you divide by 1.6, it will give you miles. Yeah?
19 point something.
Yeah. 18 something, 19. 18 and 19 about, yeah? So we don't go in that calculation anymore because we don't want to stuck there.
Okay.
Yeah? Should I remove this one?
Yeah.
Okay, now the basic start of experiments. Here we are doing the experiment, only theoretical part, not actual practical. Our birth, plumb line, yeah? About 5 feet,
Yeah?
yeah?
No.
About 5 feet, yes, I'm 5'10",
Four,
yeah.
4.5.
Not 4.5, sorry, 5.
Well, I'm figure 5 feet, yeah.
About, yeah. Anyway, doesn't matter.
Okay.
Wherever you hang this one, it remains straight.
Yes.
So you don't need to make sure whether something is particularly perpendicular or not. It always remains perpendicular.
Yes.
And when the sun is there and measure the shadow in the bottom on the floor, right? So it will give the angle of the sun at that place, right?
Yes.
Now we draw the diagram. This is the object, this is the sun, and too much far away, and this is the shadow. So this is shadow length, say 1. If the height is about 3, so sine of E is equal to 1 divided by 3. Yeah? If it is a 0.5 sine, then we get 30 degree. So it's a 1/3. 1/3 means 0.33. Right?
Yeah.
So what will be the degree? 0.33 sine, what will be the degree?
10.
About 20.
Huh?
Oh,
I thought 0.5 was 30. A
Yeah.
third of that is
So
20.
divide it. It's about 1/3 down, 1/3 down, 1/3 down. So 10 degree will be 0.16 something. So, yeah, 15, 10 degree. Yeah, just chop it as we did last time. Right? So it means sun is about 10-20 degree in south of us. This is how the experiment is done. So what is the purpose of doing this?
Yes.
Awesome guy do? Tried out?
I'm still writing it.
Okay.
I'm at point.
Now we are not doing the experiment in one place. We ask others, okay. You do there, you do there, you do there, you do there. Yeah?
Oh, yes.
Everybody does the same experiment at the same time. At the local noon time. Local noon time is 12 p.m. 12 p.m. વોચના નહીં. Right? GMT હોય તો GMT means અત્યારે આપણે 1 hour ahead કે બરાબર ને? તો અત્યારે આપણે 1 p.m. થાય ત્યારે when this is a 1 p.m. it is 12 p.m. GMT. Okay? So let us take 4 places. This is a London.
So that gives you the angle.
Yeah. So this is a Southern Sea,
Yeah.
this is a Cambridge, this is Oxford, this is Dover.
Yeah.
Yeah, okay. They are about 60 kilometers apart from each other. Just example, assuming that they are 60 kilometers apart from each other. So if they do the same experiment at the same time, at local noon time, right, they will get a shadow. This person will say, oh, I have got shadow about 30 centimeter. This will say, no, I have got 28 centimeter, right? London says, oh, I have got 31 centimeter. Sorry, not 30, 28, 29. And there people guess, oh yes, 29, but our shadow is not in straight line, but bit different. This will get this side, and this will get this side. So shadow will be not in line exactly, but bit difference.
So that's different triangles.
Yeah, very small triangle. How much? That much. About centimeter. That's why I put here it gets 29, here it gets 30, here it gets 28. So it means, guys, we can calculate this difference is 60 kilometer has get us difference of shadow only 1 centimeter. Right? So the height is more, shadow will be more different. So in that case, it gives us idea, okay, this is about half a degree, and half a degree gives a shadow difference of 1 centimeter, or about 5 feet, like that. Right? So it gives the measurement of the earth half a degree. Right? And we know that how much earth moves in every minute. Do you have idea? Yeah. Every 4 minutes it takes 1 degree.
4 minutes.
Yeah. After calculation, 360 degree,
Yeah.
right? Equal 24 hours. Right? So 1 hour equal 15 degree. Right?
Correct.
And so 4 minutes equal 1 degree. Yeah? So that's we are going to use to measure the how much it takes time. So now we are linking in time as well. Yeah. Okay, so we have got something idea, takes about half a minute. So we ask them to repeat it after 2 minutes. So after 2 minutes, the earth will rotate about half degree. Yeah? So what will be the difference? The shadow will come in this line and shadow will come more away. Double of that. Yeah?
That's like,
Yeah. London shadow also will be about half of that, means 1. Here is 2. So it gives idea how much it moves every minute. And once we confirm that this is a half a degree, about 50 or 60 kilometers, so 1 degree equal to 0.5 degree equal 60 kilometer, 1 degree equal to 120 kilometer, sorry, yeah. And 360 degree equal what? About 40,000?
yeah. Which was the first.
Yeah, so that is how, without measuring Earth, we assume that Earth is that much big. So, if it is a 40,000 degree, we can calculate what is the diameter of Earth. Diameter. It comes about 12,000 kilometers. We can use 2 pi r here to understand, make sure it is correct. बराबर? समझाणु कहीं doubt? Any question? Once you got this one, you can divide it by 2 pi. So you get the radius, and double of that is 12,000. Is the diameter of Earth.
That's 12,000.
Yeah. 12,000, yes.
Is that kilometers?
Kilometers, yeah. I'm trying to make only one metric system so we don't get confused. Right? Okay. Once you notice, yes, I did it, then I go further. Now, bhai, bolo, tamne jara. Kind doubt? Confusion? ક્વેશ્ચનો તો પૂછી લો અત્યારે જ, કારણ કે આના ઉપરથી હવે આપણે આગળ ગણતરીઓ કરવાની છે. હજી આપણે અર્થમાં જ અટક્યા છે, સ્પેસમાં જવું છે એટલે આગળ વધવું પડશે.
So 40,000 is what?
40,000 is
Total distance.
360 degree Earth.
Yeah.
With circumference, yes.
Oh, it's 360, not 36.
Yeah, no, 360, yeah. We just multiply this one and this
Yeah,
one.
yeah.
That's
But that's the distance
it.
from
Goes round, circle.
us, the girl.
Yeah, our circumference of the Earth.
Orbit.
Not orbit, orbit is circumference means Earth. Earth goes round. Round circle of the Earth. And orbit is all going around the sun.
Okay.
Yeah? મને એમાં તો કદાચ પૂરું થઈ જશે, પણ don't worry. The rest of the part we will take on
2 weeks. Week
no,
after next.
yeah, 16th of October.
Oh, not next week?
9th ના નોરતાનો આઠમ છે.
Oh.
એટલે નોરતામાં વાળી બહુ બિઝી હશો એટલે વળી
So we don't come next week.
no, not next week, but it's a revision time for you. You memorize everything. When you come another week, you must remember this one and get ready what you have got questions so we can sort out the question answers, yeah?
I was working over your calculations
Uh-huh.
with a friend of mine from my poetry society.
Uh-huh.
And after, well, I couldn't believe that he could get it so quickly. So I said to him, tell me, how do you do this so quickly? And he said, well, I worked with the centre where Turing did all his decoding
Right.
during the war.
Okay.
Turing was the master of the decoder.
Should I remove this one?
So 0.5 is the centimeter of the shadow, right?
No. What we have got from this experiment, we got that this 60 kilometer distance is equal to about 0.5 degree. By calculating the shadow and the difference.
Yeah, so it's the shadow
Yeah. So what we said here, we get shadow
0.3.
0.33, then it's a 20 degree. Here we get a small difference of only 1 centimeter or something that is equal to that much, half a degree like that. Right? So either we use the table or we use our technique. Divide. And that's how I did here. I just put everything on scale. Yeah? 1 centimeter sun is that much far away. Yeah? That is a scale. And same thing, anything have a difference of half a degree, it gives about 1 centimeter difference at this distance.
Without the sun's distance is times
Yeah.
that.
So shadow also works the same way. If you hang like this one, it goes a shadow about 1 centimeter difference for any object. This is our measurement rule. Okay, should we proceed further? Any doubt? Bye. કાંઈ ક્વેશ્ચન પૂછી લેજો ડાઉટ હોય ન સમજ પડે ઓલરાઈટ હવે આપણે આગળ વધીએ we move to the moon. We'll calculate everything about earth rotation speed, earth speed in the space while it's going around the sun. So now same way I'm not going to count again. Same way, think about moon. How much moon moves in 1 second? Barabar? So let's see. This is the moon orbit. Around the earth. It takes 28.5 days approximately. Right? We know this distance is 300,000 kilometers. We are just taking number what is given by NASA. Okay, whole list is there. Which planet, at what distance, how long it takes, what is the speed, everything.
So these are not Puran numbers.
Now we are using the technique of Puran. Why we take this one? To make that what we are doing is correct.
Okay,
We are matching the science numbers.
okay.
So we can calculate 2 pi r as like we did it for Earth. Divide by 28.5 days multiplied by 24 hours multiplied by 3600 seconds. Yeah? That is already calculated on paper and ultimately gives us answer. It hardly moves a kilometer per second. Means less than a kilometer per second. That is orbital speed. So anything running faster than this on the moon,
Will take off.
yeah, that's it.
So if those astronauts had run a little faster, they would have taken off.
Yeah, that's it. Even they can't walk normally because see the speed of rotation on the surface is about 4 meters per second. In the next slide. So generally we walk like this, 1 and 2 in 1 second. So this is about 3 meter distance. Or like minimum 2 meter distance, yeah? So if we try to run it, then we run faster than this.
And we take off.
Yeah. So it means we can't stand on the surface of the moon.
Yeah,
If we try jump, it jumps like that and we fall down. When we fall down, we crash.
yeah.
So it is not safe to walk or run on the moon surface. So that is why they make a system. Okay, don't do this. Kangaroo speed.
Use of heavy moon moves
Yeah.
to keep
Yeah.
keep
So
it grounded.
this gives us an idea. What is the rotation speed and what is the surface of the moon moves at per second. So we should follow that principle and we don't go beyond that. If we try to run faster than that, we are lost.
But then when they jump, it's the same thing, no? They're getting that, they're going up above the
But
speed.
what they are doing, they are not jumping like as we are doing in Earth.
Mm.
They are doing just
Figure.
by toes only. Otherwise, the gravitation of the moon is 1/6 as we calculated last time. So, who is doing a high jump or person doing 1 meter jump, he jumps 6 meters there and then he crashes down with the fractures. So, that is how everything is calculated. Now we come to the Jupiter. If you remember last time we did one of the example of Jupiter. How far is the Jupiter from the Sun?
Height AU.
Yeah, this is the Sun. This is the Earth. Get this one. And this is Jupiter. This is a 1. This is a 5. Total 5, sorry. That's it, 5. 5A.
AU.
Yeah. It's called astronomical unit.
Oh, okay.
However, now we are not using kilometers, miles, nothing.
Yeah.
The distance between the Earth and Sun is called 1. It's called AU. It is taken as a basic. And this is 5 times. So, last time we said when something is about 5 times away, gravitation force 5 times pi. 1 upon 25.
What is that, 5 times 5?
Gravitation force
Yes.
by the square. So, if it is 5 times, it divides by 25. So, gravitation force 25 times smaller. If you go 10 times far away, like a Saturn, it will fall by 100. Right?
So that's 1/25th.
Yeah, that's the 1/25th. And the speed of the Jupiter will be square root of 5.
2.
Because Earth's speed we have gone what is 30 kilometers per second. So Jupiter's speed will be 30 divided by square root 5. That's the principle we discussed last time. Or forgot you? Do you remember one? Or do you want to revise that one again?
That should help us through.
Yeah. It's the same principle, just if you go 5 times away, the speed reduces by square root 5. Reduces means divide by. Right? So what is the answer? It's about, what is the answer?
Square root of 5, 2.25 roughly?
Yeah, 2.2 about, yes.
2.25.
Yeah, so,
30 divided by 2.25.
Yeah.
So about 17?
yeah, 17, 18, yeah.
17, 18?
Yeah, 18, that's it. So here you got the answer.
Kilometers per second.
Per second, yeah. Here you got the answer. See, and that is the Jupiter. What is the speed? Rotation speed.
0.4.
It's a period. We are looking for do the calculation. We got this one wrong.
13.
Yeah.
Okay.
No, don't go in that one. Do the calculation. Square root 5
Okay.
2.2.
and
Okay.
30 divided by square root 5. Square root 5 is equal to 2.2.
2.2, 2.24
Yeah.
or something. 2.25, I think.
It's given already there. here I have a print mistake. I have multiplied it. It's not multiplication.
Divide by.
Yeah, reduced by means divide by.
Where's that? There.
That should be divided by. So 30 kilometer divided by square root 5 comes 13.41. So it gives an idea how fast is Jupiter is moving per second. Same way, how fast it moves. What is the gravitation of the Jupiter? We calculated the gravitation of Jupiter is about 2.5 times than the Earth. Do you remember that?
No.
Okay, so you haven't realized it.
If it's far away, the gravitation is less?
Less, yes.
Less.
Less how much? It is said, do the square and divide by the square, that's it. Same thing, second, next example, as we said, it is about 10 times far away. So, speed will be square root of 10.
Yeah.
That much will be divided by, so it will be reduced by that much. So, square root 10 is about 3 something, 3.1. So, 30 divided by 3.1, it comes under 10 kilometer. So, here it's given about approximately 9.48. Yeah? Everything is there. So, you don't need to calculate. Just try it on calculator or whatever it is. And just showing that how we calculate the speed of the all planets, gravitation of the all planet, and how, right, orbital speed, circumference speed, whatever it is. So we can calculate everything in the space without going there or without calculator or without any tables. This is a simple principles used in Surya Siddhanta and simple experiment measuring the shadow. Okay, so this is the just basic idea. Now I want to make sure whether you got the right thing or not. Here Jupiter orbital period is given 11.86 years. Under the Jupiter,
11.2.
No, the orbital
Oh.
period.
okay, 11.86 years, right? And we have calculated it 11.2 years. So why is the difference? So is that our method is wrong?
Accuracy of the calculator.
That's it. We have taken a round figure far, about 5. Actual figure is 5.2. Yeah? So put the same things. Same formula in 5.2 instead of 5. Do the square root of 5.2 and 30 divided by 5.2 will give 11.89. Right? So I haven't taken a complicated number just to show you how we can calculate. So I have taken the round figures to show you how to do it.
Yeah.
You use the correct numbers and you will get everything. That's why I put all these numbers to recheck it. So whatever calculation what we are doing is not against present science calculation. ભાઈ બરોબર હું અહીંયા બ્રેક પાડું છું 5 મિનિટ અને પછી આપણે આગળ વધીએ.